All right, in this final video segment on properties of logarithms, we are focusing our attention on the change of base property. And this is a really handy property to know because many times we want to evaluate a logarithm and we would use our calculator to do this, but many of our calculators only have the capacity of evaluating logarithms with a base of e or a base of 10. So this handy dandy property allows us to change the base of the log that we want to evaluate to anything we want, but usually we change it to base e or base 10. So this property says that if I have a log with a base of b of some value m, this is the same as the log with a new base, let's just call that base k, of m, divided by the log with that same new base of our old base. Okay, so that's really helpful because we can now change our base to anything we want it to be. So like I said earlier, often we just change it to things our calculator is really friendly with. Common logs, which are just log of m divided by log of b. Or we might consider using natural logs. So that would be equivalent to ln of m divided by ln of b. So either one of those. Depending on what your textbook or your software or your exercises say, perhaps you'll be directed in one way or the other, but in these examples we will do some of each so that you know that it doesn't really matter. Okay, so we're going to start with this example. Log base 5 of 400. So first let's find out what exactly this is equal to, and using this property I'm going to, let's do this one with common logs. So we'll use just log. I'm going to rewrite this as log of something over log of something else. Notice that our argument of our initial log goes to the numerator, the base goes to the denominator. So here our argument is 400, it goes to the numerator, and our base is 5, it goes to the denominator. Okay, so now I can punch this in my calculator and get a decimal approximation. So I'm going to do that here. I'm going to actually move this a little bit so that we can see both the calculator and this at the same time. So let's go ahead and clear that. And I'm just going to take the log of 400 and I'm going to close up that argument, and I'm dividing that by the log of 5. And I get for my answer 3.7227. Let's use 3 decimal places here. So we'll say about 3.23. So about 3.23. Well, now I can go back and check that my answer is correct, that I actually did this correctly by recalling what I know about the definition of a log. Because if I go back to this, I'm really saying that 5 raised to this power should be equal to 400. So let's just check that in our calculator, okay? So let's do 5 raised to the 3.73 in our calculator, and let's see what it gives us. It gives us something, oh, I should have done 3.723, right? Sorry about that. 723, and that's somewhat very close to that 400. Now, why is it not exactly 400? Well, that would be because we did not put this whole approximation or the exact value in as our exponent. So this just gives us, if it's very close to 1 decimal place, we know that we did pretty good. All right, so let's go to this next example. And our next example is log base pi of 63. So this time let's use natural logs. So that means that we're going to write this as a ratio of 2 natural logs, ln and ln. And remember, the argument goes on top, ln of 63. The base goes on the bottom, ln of pi. And here is where we would want to get some kind of approximation so we can check ourselves in the calculator. Okay, so what is that approximately? Well, let's double check. So let's look. ln of 63 divided by ln of pi gives us approximately 3.619. Now, if I want to check that I'm exactly right, we can use this handy-dandy little trick on our calculator and say pi raised to the, and then I'm going to use my answer button, okay? So on a TI 83, 84-ish model, you just do second and the negative symbol, and it pulls up the answer. And if I take pi and raise it to the answer, I should be exactly back to 63. Okay, so outstanding. Looks like I'm doing okay. All right, moving on to the last two examples here. Log base 0.1 of 19. What does that equal to? Let's do this one with common logs, and it really doesn't matter. You can do either one. Log of the argument, which is 19, divided by the log of the base, which is 0.1. And that is approximately, oh, I don't know. Let's use our calculator and find out. Log of 19 divided by log of 0.1. And it looks like that is about negative 1.279. Okay, and this last one, I think you're probably starting to get the hang of it by now, but we'll do this last one together. And again, let's use something natural. Let's use natural logs here. ln of 87.5 divided by ln of 1.4. Okay, and using our calculator for an approximation here, I'm just going to cover it up. ln of 87.5 divided by ln of 1.4 gives us about 13.290. Okay, and that's change of base. See you next time.